welcome to CAM. This is Computer Aided Machining and Manufacturing. I'm Mr. Mulhendrick. I go by Mr. Mo. So come on in, I'll show you around. If you've never been inside a machine shop before, I'll show you a few things. These are some sample projects that we've worked on. We've got an assortment of crab mallets, which are pretty cool. And we used this to kind of get more proficient using the lathe, which I'll show you in a little bit. We've got this, which seems very simple. You've probably seen this at Cracker Barrel. It's the peg game, but it's a lot of math involved here, so it's another good project. And this is just an example of a part that is used. So we take a drawing like this, and we'll take a simple block of aluminum, and then in the end we've got it turned into something that's a lot more intricate. So this is an engine base for something that we manufacture. I'll take you on to the lathe section. This is a standard gearhead lathe. This is one of the machines that we use all the time. And this will be used to make cylindrical objects like this crab mallet handle, create the knurl, and create the head of the handle. And so if you, as you see, we've got about 10 lathes in here, and they're all essentially the same. So we've updated, we got rid of the old equipment, we've got some pretty nice stuff here. So this is one of our newer milling machines. This particular machine has multi-axis CNC, so we're able to create different shapes. So an example of some of the work that can be done, we took a part which is called a T-slot cleaner, and we were able to set that in the machine and cut out a profile so it will duplicate the part, which I think I'm showing to you correct. So with that, we can also get in here, take and go into our program and actually machine circles, squares, and various other shapes using 2-axis. So this machine is capable of moving itself around. All right, this is the CNC section of the lab. What I have open here, hopefully this will show up on the video, is a 3D illustration model of a part that we're going to manufacture. And this part is actually just a simple vise handle. So this would go on, I don't know if you'll be able to see it, this would go on a vise like this, open and close your vise. And this piece, believe it or not, it's like about $50 to buy it. So we were able to create a program using Mastercam and then input that program into our machine, and then we can manufacture a part. So this machine, which went to sleep, will change tools and manufacture the part. All we have to do is program it and set it up. Another portion of the CNC lab is our simulators. So each of our machines comes with a simulating control. So this gives you an opportunity to practice before you start breaking tools and crashing machines. So it's exactly identical to the controls on the machine. So we've got 4 simulators. We're going to have a 5th one. We've got 2 milling machines. The second one's not here yet, it's on its way. And we've got a lathe, which I'll show you next. So this is our CNC lathe. Same controller as the milling machine, just a few buttons have changed. But it's another Haas machine. And we tried to standardize that to make it a little bit more simple. So with this machine, you can do everything that you can on a standard lathe, but you can repeat it very easily. So if we wanted to make 100 crab mallets exactly the same, we program it in here, hit the green button, it's going to make the part each time identical. So this is our classroom, and we have a very nice computer lab here. So we do a lot of work in here using CAD programs, using the projection so that you can see what's going on. If you can zoom in on the screen, give you an idea what the CAD looks like. So this is an example of an engine that we have that we build. So we make all these prints from scratch. A lot of numbers, a lot of dimensions, and by the time you leave, you'll be pretty proficient with this if you're to join this. This is our tool room. As you can see, maybe I'm a little bit OCD. As I'm looking around here, I notice I'm missing a pair of pliers, which bothers me, but I know where they're at. And we've got to keep track of all this because it's a very expensive program. Each tool in here is very, very expensive. A lot of them I'm sure you recognize, but then we have a lot of precision tools, precision measuring tools. This is an example of a measuring tool, and this will read down to within 1/1000th of an inch. We have the capability to read within 10/1000th of an inch. So if you're a picky person, this is a good place for you to be. So let me tell you a little bit about the program. So you'll start in here. It'll be a 4-year program, the first year being FOT. During that time, you'll do some rotations to other tech areas. But the primary purpose is to get the foundation for what you're going to be learning in the shop. So you'll be doing things like operating drill presses, saws, layout operations, as well as a lot of math, the beginnings to CAD. And then when you move into your second year, your sophomore year, you'll get into running the mills and the lathes a lot more. In junior and senior year, you'll get into the programming and the CNC equipment. So by the time you leave, you'll have a very good opportunity to go out, earn a good living. I've got students that are working at places like the Applied Physics Lab at Johns Hopkins and other really good jobs. So leaving here, you can go straight into engineering. There's a lot of opportunities. And a little bit about myself. I started out in a program like this. I don't even know what year that was. Let's just say 1989, something like that. So it was a 3-year program. Prior to that, I worked a little bit in a machine shop from the age of about 12. And then when I graduated from high school in '91, I joined the Air Force and went straight into machining and manufacturing, got my welding certifications, and did that for 20 years, retired, and then found this position, started teaching welding. So I really have a lot of respect for the program. I love what I'm doing, and it means a lot to me to encourage you all students, people, to come along with me, learn this program, and get out and actually start manufacturing things.